Hello students, this is 3-6, um, compound inequalities. This one's going to be a little bit of a challenging lesson, but I think you guys can get it. Let's go ahead and get started. Okay, lesson 3-6 starts on page 216. This is one I'd recommend maybe having your book handy to review the lesson. All right, well let's go ahead and get started. So here we're going to learn about solving a compound inequality. We're solving inequalities using the words and or. Okay. Now, what do I mean by a compound inequality? Compound inequality is an inequality that basically uses two inequality symbols. Okay. Let me give you the example here. And creates a range. So when you graph it, what you're going to see is there's a range from one point on the number line to another. In this case, from -3 to +4. Let me explain. Here's my inequality statement. X is greater than -3 and X is less than or equal to 4. So if I graph that, let's see, X is greater than -3. So I have an open inequality and a line going this way. And X is less than or equal to 4. So I have a closed dot, a closed inequality, and it's less than 4. So where both of these lines are true would be the compound inequality. Now let me show you how I'd write this as one inequality statement. I'm going to go ahead and put X right in the middle. Okay. Now we said that X is greater than -3. So I'm going to write it this way, that -3 is less than X. And I'm also going to write that X is less than or equal to 4. So I'm going to write less than or equal to 4. Now, I have one mathematical sentence here, but there's two inequalities within the sentence. Okay, looks a little confusing, but you guys are smart and I know you can get this. Now when you have an or statement, it creates a split. Let's take a look at our number line here. I have a line going low and I have another line going high, and there's a difference in between them. Okay, so in the or statement, I have this inequality: X is less than or equal to -4, or X is greater than 1. Okay, now in a situation like this, it cannot be both, but we use the word or because sometimes you might end up with a situation saying that it can be one or the other, but it's not going to be in between these two possibilities. It can either be less than here or it can be greater than here, but it cannot be in between them. Okay, so that happens sometimes. You will get inequalities where you have a split. Now, all the split means is that the value of X can be lower than -4 in this case. It can also be higher than 1, okay? But it cannot be between 1 and -4 because that would not be truthful with the statement. Now, with an or statement, it's somewhat difficult to come up with a real life situation where that would work. I'm sure there's probably an example or two in the book that you can look at that'll explain it in like this or that could happen, but to save time, I'm just going to go ahead and continue. So this is known as a compound inequality. Now, you'll notice with the and statement, I wrote everything in one line. But with the or statement, it's better to keep them as two separate inequalities, but then graph them on the same number line. Okay, so there's no reason to write this as two separate statements. It'd just be more confusing to do that. Now, where do we get the word compound from? Hint, compound means more than one. So a compound inequality is an inequality that has more than one inequality symbol. So basically it's got two symbols in it. Now there's another word that popped up in the definitions here, and that is inclusive. Inclusive simply means a closed inequality. Now remember, closed inequality is one where we have a closed dot. A closed inequality where the values are included. Let me show you the difference. This one is an inclusive inequality. X is greater than or equal to 7 means that 7 is included as possible answers. So for example, if I know that x is greater than or equal to 7, then I can start and say 7, 8, 9, 10, 11, and so on would all be possible solutions or answers. Now this one is not inclusive. X is greater than 7. Now as you remember, this is an open inequality, so it has an open dot. Now an open inequality means that 7 is not included as a possible answer. Okay, so for something like this one, I would have to say, let me move up here. I just realized how low I am on the screen. Wasn't looking, but let me say again. So this one means that 7 is not included as a possible answer. So if I have the inequality x is greater than 7, then I would probably start at 8. I would not start at 7. And if you really want to get technical, I could start at a decimal, like 7.1, 7.2, and so on, but it just has to be larger than 7.0. Okay? Any questions in that? Obviously, you'll have to email or text me if you do at this point, but let's go ahead and continue. So inclusive simply means that the answer is a closed inequality, and the closed inequality includes the number as part of the answer. An open inequality is not inclusive, and it just means that it does not include the number as part of the answer. All right, so let's solve a compound inequality, particularly this one here using the word and. Now, if you want to write this one down, or you can look it up in your book, because this is the same one that's in the book, I want to show you the steps to solving this compound inequality. So, it is -3 is less than or equal to m minus 4, which is less than -1. Don't be alarmed, okay? Now, note here it says to isolate the variable on, well, that looks like or, on both sides, left and right, okay? So I'm going to use my finger here to show you what I mean. If I cover this up, you're probably like, I could solve that. M minus 4, I use IOB, isolate M, I would add 4 to this side and to this side, right? And you could probably solve this inequality. You think, I want to isolate M to both sides of the inequality, so I would add 4 to both sides, okay? So when you have a compound inequality written all on the same line, you simply do what you just did, but you do it twice. Actually, 3 times. Let me show you. I want to isolate the m, IOB, by opposite operation to both sides. So m has 4 subtracted from it. In order to isolate the m, I must add 4 to turn that to 0. Now I must do it to the left and to the right side of my inequality here. So I'm going to add 4 there, and I'm going to add 4 there. See how I'm doing it 3 times. Now the first one, the one that I'm using to isolate the m, is going to be simple because I just pick whatever number I can to make the additive inverse so that it will eliminate everything next to m. So now I'm going to rewrite m by itself because it's been isolated. Let me rewrite my inequality symbols. I'm just bringing them down to the next level. Now let's solve on both sides. What is negative 3 plus 4? That would be 1. So I'm going to go ahead and write 1 in my next level here. What's negative 1 plus 4? That's the same as saying 4 minus 1. So that would be 3. Positive 3. So I now have the statement 1 is less than or equal to m, which is less than 3. Now, the first thing I want to check is my variable isolated. Yes, meaning that the only thing next to the variable would be operational signs, like equals or, sorry, not operations, but the inequalities or equal signs, the only thing that's next to it. So it is isolated. There's nothing left to do, okay? So, in that respect, the next thing I would need to consider is how on earth would I graph this? So go ahead and draw a number line. Now, if you're doing this at home with me, then that might help make it easier because you will get to practice while you're actually watching the video. Okay. Now, as I had said before, on the number line, I only want to put the numbers that are in my statement here, my inequality statement, or my solution. So I have positive 1, which goes right there on the number line, and I have positive 3, which goes right here. Okay. Now I'm going to start with 1 here and look at its comparison to m. Okay. So now it's saying that m, I'm reading this backwards, is greater than or equal to 1. Now this is a closed inequality, so my dot is going to be closed. Now the value of m, if it's greater than, then that means that its arrow was going to be going this way. Now I'm not going to finish my arrow just because I know this is a compound inequality. Okay. Now the second statement here is m is less than 3. So 3 is where I want to put my next dot. Now since it's an open inequality, I'm going to have an open dot. And then if it's less than, then my line's going to go down. So I now have my range. So the value of m could be between 1 and 3. Okay. On the 1 side, it could include 1. So, for example, it could be 1 or 2. But on the 3 side, it cannot include 3. So it could be 1, 2, 2 point something, 2.999, but it cannot be 3. Okay? So the range is basically from here, including 1, to here, anything smaller than 3, even 2 point something decimal, but does not include 3. So it's interesting because this side is inclusive, meaning it includes the number that it's at, but the right barrier here, 3, is not inclusive, meaning it does not include 3. So it could be 2.9, but it cannot be anything as large as 3. Okay? Now, in a sense, if I were to write these as two separate inequalities, I would have 1 and then I would have a line with an arrow going this way. And I would have 3 open dot with an arrow going that way. Okay? You don't have to do this, but I'm just going to draw. This would be the arrow left over from 1, and this would be the arrow left over from 3. Okay? It's just showing that the blue section represents the range where both of those arrows overlap each other. Okay? Any questions so far? All right, let me go to the next question then. Now, to solve an inequality with OR. Now, to solve an inequality with OR, what you need to do is to solve both inequalities. Hold on just a second. I'm going to pause. Okay, I'm back. Anyways, so solving the inequality with OR, you want to solve both inequalities, but graph them on the same line. Okay? So with this one, it's not written very complicated. It's not written as two separate, I mean, it's not written as one compound statement. It's written as two separate statements. So let's go ahead and solve. I'm going to go ahead and solve the first one. 3t plus 2 is less than negative 7. All right. So we solve with IOB, isolate opposite both, but we always start with addition and subtraction first. So negative 7 minus 2 would be negative 9. I know integers can be a little confusing, but I have negative 7. I'm subtracting 2 positives, so it becomes more negative. So I actually add my absolute values here to write my answer as a negative. On this one, the 2's cancel out, so they are gone. So let me write my next line here. I have 3t left here, and I have negative 9 there. Now I want to isolate using multiplication or division. In this case, I have to unmultiply by using division. The 3's cancel out, leaving me with t. Now, IOP says to do it to both sides. So negative 9 divided by 3 is negative 3. So my solution is t is less than negative 3. Now, let's go ahead and solve this one. I subtract 5 from both sides. 1 minus 5 is negative 4. I'm going to rewrite my inequality. 5 minus 5 cancels out and becomes 0. So now I have negative 4t left over here because all of that's been removed. All right, now I've solved with IOB, but this time I'm using multiplication or division. So negative 4 cancel out, leaving me with positive t. Negative 4 divided by negative 4. That leaves me with positive 1. But wait, I divided both sides of my inequality with a negative, so that means I'm going to switch my sign. Remember, if you do a negative to both sides, whether it's multiplication or division, your sign switches. So now I have t is greater than 1. So with the OR statement, let's go ahead and make a number line. Now, if you remember I said before, when you create a number line, the only numbers that really need to be on the number line are your solutions and 0. Okay? Since I have two solutions, then I'm going to be putting two numbers on. Negative 3, I'm just going to estimate it's around here. I'm not going to go ahead and count and tally mark the whole number line. And then positive 1 is probably about here. Okay? Now, let's make dots for both statements. So t is less than negative 3. Okay, that's an open inequality, so I'm going to put an open dot on negative 3. And my arrow is going to be pointing to less than. And I have another statement, t is greater than 1. So I have an open inequality, so an open dot. And my arrow is going to be going to greater than. So my OR statement shows that I have the value of t could be less than negative 3, or it can be greater than 1. Now, keep in mind these are not inclusive. So in other words, it cannot be -3 and it cannot be 1. It could be bigger than -3 or it could be smaller than 1, but it cannot be those numbers. Why? Because they have open inequalities. Now, students, when we talked, you did say that you would prefer to have maybe a few more details. There's a complicated problem. It's on page 218. It's problem number 3. And it was a problem asking a question. It's saying that if you were taking a bunch of tests, and in order to pass with the B, you have to get between 84 and 86 on your last test. And these were your previous test scores. So the question is, what is the range that is needed to, or what test score will you need to get in order to pass with a B? Okay, now your answer is going to show up as a range. Now I went ahead and wrote out all the information here for you. So let's go ahead and take a look at the problem. What are we solving for? We're solving for x. What does x represent? It represents the test score that you would have to get in order to get a B in this class. Okay? So to get a B in the class, you have to get between 84 and 86%. Okay? Now, when you average, you divide by the number of things that you're adding together. So there's 4 elements. These are your 3 test scores, 86, 85, 80, and the last test score, which you haven't taken yet. Now, I'm not talking about your actual test. I'm talking about the question, problem 3 here. So the first step is we want to eliminate the fraction of 4 here. So how do we do that? We multiply the entire inequality times 4. Okay, so 4 times 84, 4 times this entire fraction here, which basically is just going to eliminate that 4, and then 4 times 86. Okay, I'm going to grab my trusty calculator here. All right, 84 times 4, I'll just go ahead and do that for you, is equal to 336. Now let's do this side, 84 times 86. Oops, I think I added 84 times 86. Oh, I'm sorry. That was 4 times 86. That's why I kept getting some ridiculously large number. So that's 344. Okay. Now I'm going to go ahead and rewrite the rest of my statement here. Now I'm going to go ahead and add these numbers together. 86, 85, and 80. I'll use the calculator again. 86 plus 85 plus 80 equals 251. Okay. Now again, I'm doing a complicated problem here because if you come into a complicated problem, I want you to have a little bit of practice with them. Okay. Now we want to isolate x because we have simplified here. We've gotten rid of the 4 by multiplication by 4. And we added all of these like terms together to get 251. So now, to isolate x, I want to subtract 251 from both sides, or actually from all 3 sides. 6 minus 1 is 5. Cross out 3, make it 2, put a 1. 13 minus 5 is 8. 2 minus 2 is 0. Okay. Now let's do this side. Minus 251. 4 minus 1 is 3. Cross out 3, make it 2, put a 1. 14 minus 5 is 9. Okay. So now let's write down what I have left. So I have 85, bring down my inequality, is less than or equal to, that's only thing that's left there is x, which is less than or equal to 93. Now I've made my inequality statement here. So what does this mean? This means that given these test scores, in order for me to get a B in the class, my last test score has to be 85 all the way to 93. Okay, if it's higher than 93, then that would give me a B plus. If it's lower than 85, that would give me a B minus. But in order to get a B, it has to be, my score has to be between 85 and 93. Okay, and if I were to write that on a number line, which I'll just go ahead and give you, here's 0, here's 85, here's 93. Then I would write it like this. That would be my range. Okay, I hope that helps. Please enjoy this video.